Okay, here's our first problem. Remember, we have to read this through 3 times, so the first time we're not going to write anything down. So just read it. So here's our example 1. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. Whew, okay. So my goal in this problem is to find the dimensions of the original square. That's our goal. Good. So we want to find the dimensions of the original square. That's ultimately what we want to do with this. Okay, let's go back through here and figure out what it is that we know. So, if the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original. Holy cow, that's a lot. Okay, if the length of each side of a square is increased by 3 centimeters, that's our first piece of information. The perimeter of the new square is 40 centimeters more than twice the length of each side of the original. Find the dimensions of the original. Okay, let's do this thing. Now, we're talking about a square here. So because we're talking about a square, anytime you're talking about geometry, it is a good practice to draw a picture. So I have 2 things. I have an original square, and then I have a new square that we're talking about. So let's try to pull off an original square and a new square. So let's see what kind of information we know. The length of each side of a square is increased by 3 centimeters. So if I want to find the dimensions of my original square, what would that be? How can we represent the side of the original square? That's our unknown. So what is typically represented with an unknown? The variable, right on. So I actually have let x equal the side, wow, this pen isn't working so hot, of the original square. So that is my x value. And this is a square, so what do you know about a square? All the same. So if each side of the square is increased by 3 centimeters, what does that mean? Add 3. And you know it's a square, so all of those are the same. Okay, now what do we know? We want to find the dimensions of the original square, but it tells me the perimeter of the new square is, what does is mean in math? Equal. So perimeter of a new square, so perimeter of the new equals 40 centimeters more than being plus, twice the length of each side of the original. So twice, and how do we know what the side of the original is? Da-da-da-da-da-da, our let statement. So that is our x. So the big question here is, what do we do to represent the perimeter of the new square? Well, so the perimeter of the new square, so I'm going to erase this part of it, and let's fill in what we know about the perimeter of the new square. My perimeter of my new square, so perimeter is add up all the sides, and if it's a square, all the sides are exactly the same. So this is going to be 4 times my x plus 3. Voila. We just came up with our equation. And this is a linear equation, so that's something that we could do all day, every day, nice and easy. So just solve this real quick. So we end up with 4x plus 12, when you distribute that 4, is equal to a 40 plus 2x. Get your variables together. I like to make my lead coefficient positive. So I'm going to subtract 2x from both sides. And because I'm moving the x's to the left, I'm going to go ahead and subtract the 12. Just get all of that taken care of at once. So I now have 2x is equal to what? Oops, my equal sign didn't come up very good. What is that, 28? Check my math, make sure I'm on it. Divide both sides by 2. So then x is equal to 14. Well, congratulations, x equals 14. What does that mean? I don't know, let's look back. What kind of information do we have? We know that x represents the side of the original square. So if x is 14, we know that 14 is the side of the original square. Woohoo! What is this measured in? What is my unit of measure? Centimeters. So here we go. We're going to write our therefore. The dimensions, my poor pen is struggling, of the original square is 14 centimeters. And you know it's a square, so all the sides are the same. Ta-da! You've done your first application problem. See, it wasn't so bad.